In this video, I am going to share some amazing strategies to keep your learning process flowing effortlessly. If you want to become master in learning, never run out of trial and error method. Stick around and let's get started to be spontaneous. You try anything and everything that comes to your mind without overthinking. I'm perceiving you to be perfect and I'm there to teach you, and be sure to watch this video right till the end so that you will be benefited. So here is an important problem flashing on the screen, and this topic is related to mathematical induction, and this is for MFCS DMS DMGT and intermediate 1A. So here we have to show that 49 power n plus 16n minus 1 is divisible by 64 for every n belongs to a natural number. See, in order to show this, the solution here is let S of n be the given statement. So what is the statement here? 49 power n plus 16n minus 1 is divisible by 64 is the given statement. So we have to use the mathematical induction part. So in order to use the mathematical induction, so we have to check for n is equal to 1. So here, after finding for n is equal to 1, if you keep n is equal to 1, what happens here in the statement? So here this is 49 power n plus 16n minus 1. So in place of n, if I keep 1 here, then this will be 49 plus 16 minus 1. So this is a 65 minus 1, which is equal to 64. This 64 is divisible by 64 for one time. Therefore, the given statement is true when n is equal to 1. So here, the statement when n is kept as 1 is divisible by 64. And therefore, S of 1 is true. So which means that the statement is true when we keep n is equal to 1. So this is the fundamental thing which we have to do using mathematical induction. And in the step 2, so what we have to do? In the step 2, we have to assume that S of k is true. So which means that we have to keep n is equal to k. So here in this we have to put n is equal to k. So what is the statement here? 49 power n plus 16n minus 1 is divisible by 64. So in place of n, so I replaced with k. So it is said that it is divisible by 64. So when this statement is divisible by 64, then this will be the quotient say. So we have to assume that this is the quotient. When 49k plus 16k minus 1 is divisible by 64, so here the quotient is m. So here if you send this 64 to other side, this will be 49 power k plus 16k minus 1 is equal to 64m. Clear? Now here, so we have to take this 49 power k to one side and you have to send the remaining 2 to the other side. See here, then 49 power k is equal to 64m minus 16k plus 1. So name it as equation 1. So this is the most important equation. See here, in the third step what we have to do? So we have to show that S of k plus 1 is true. Now we have to show that. So in this we have to show that S of k plus 1 is true. So now in the given statement we have to put n is equal to k plus 1 and we have to check whether it is divisible by 64 or not. See here, as usual I am keeping n is equal to k plus 1. So this will be 49 power k plus 1 plus 16 into this one is k plus 1 minus 1. So which is equal to, this is 49 power k into this is 49 plus this one is 16k plus 16 minus 1. Clear? So if I multiply, this will be 16k and this is 16 and this is minus 1. So here this is 49 power k into 49 plus this is a 16k plus 16 minus 1 is 15. Clear? And now see here, we have started from here. So we have started from this statement after keeping n is equal to. So after putting n is equal to k plus 1 in the equation, that is 49 power k plus 1 plus 16 into k plus 1 minus 1. So we got this one, that is 49. So this will be 49 power k into 49. See here, plus 16k plus 15. Now see, what is this 49 power k here? So in place of this 49 power k, I am writing the whole statement from the equation 1. From, see here, equation 1. So what is your 49 power k? So 49 power k can be written as, it is replaced by 64m minus 16k plus 1 into 49 plus this is a 16k plus this one is 15. See, now I am going to multiply each and every term with 49. See here, each and every term with 49. And see, this will be 64 into 49 into m minus, so if I multiply 16 into 49 into k plus this is 49 plus this one is a 16k and this one is 15. Clear? And now see here, now if you observe this one, so there is a 16k here and 16k here. And now I'm going to take 16k common from this. So here this will be 64 into 49m plus, so if I take this 16k common, so this will be 1, and if I take 16k common, this will be minus 49. Clear? Plus this is 49 plus 15. See here, this is 49, this is 15. And now see what happens here. So this will be 64 into 49m plus this is a 16k, this is minus 48 and this is again 64. And clearly this is a 64 into 49 into m. So plus into minus is minus 16 into 48. I am sending this k outside plus 64. So what I have to show? I have to show that the given statement is divisible by 64. Here there is a 64 and there is 64 here. So I need 64 here. So for getting 64, 8 8s are 64. So 18 can be written as 8 into 2 and this 48 can be written as 8 into 6. So I got 64 here as 8 into 8. So I'm splitting this as, so this can be split as, so this is a 64 into 49 into m minus 8 8s are 64 into 2 6s are 12 into k plus 64. Now I got 64 here, 64 here and 64 here. All the three terms are having 64 and now I'm taking 64 common. So if I take 64 common, then this will be 49m minus 12k plus 1. See here. So it is a multiple of 64. This is a 64 into, this is an integer. So this is an integer. As we got the multiple of 64, therefore the given statement. So which statement it is? So that is 49 power k plus 1. In place of n we kept k plus 1, that is a 16 into k plus 1 minus 1. So is equal to 64 into an integer. So it is divisible by, so this is divisible by 64. So this is what we needed. So this is 49 power k plus 1 plus a 16 into k plus 1 minus 1 is divisible by 64. Therefore, S of k plus 1 is true. S of k plus 1 is true. See, if it is true for n is equal to 1, 2, 3, k plus 1, then we say that it is true for every natural number. And therefore, 49 power k plus a 16k minus 1 is divisible by 64. Therefore, 49 power n plus a 16n minus 1 is divisible by 64. And this is how we have to use the mathematical induction. And let's start from the beginning. So this is the question which we have to explain. So in this question, we have to use the mathematical induction. So we have to show that 49 power n plus 16n minus n is divisible by 64. So according to our mathematical induction, so I have taken n is equal to 1. So in place of n, if I substitute n is equal to 1, so this is 64. So this is divisible by 64 for one time, and therefore it is, the statement is true for n is equal to 1. And the next thing is, we have to assume in the second step it is true for n is equal to k. So here in place of n, if I keep n is equal to k, so we have to consider that this is divisible by 64. So when this whole term is divisible by 64, the quotient might be M.C.A. So if I send this 64 to other side, so this is 49 par k plus 16k minus 1 is equal to 64m. So I want this 49 par n value. So I am sending these two values to other side. So this will be minus 16k and this is plus 1, and construct this as equation 1. And now in the step 3, we have to show that s of k plus 1 is true. So here in the given statement, if you put n is equal to k plus 1, see here, then this will be 49 par k into 49 plus 16k plus 16 minus 1. 16 minus 1 is nothing but 15. So in this statement, so if I keep the 49 par k value as, in this 49 par k, I replace this as a 64m minus 16k plus 1 into 49 plus 16k plus 15. So if I multiply each and every term with 49, see here. So here the last, so here there is 16k and there is 16k. I have taken 16k common. After taking 16k, this will be 1. This will be 1 minus 49, which is equal to minus 48. Here there is 164. Here there is needs to be 164, and here there is 164, and therefore in order to make 64 here, I have written 16 as 8 into 2 and 48 as 8 into 6, as 8 into 8 is 64 and 6 2s are 12, and therefore in the three terms we have 64 common, and therefore have taken 64 common here, and therefore the remaining thing is 49m minus 12k plus 1. So which is again an integer. This is the multiple of 64, therefore this whole thing is divisible by 64, and therefore this is what it is asked to show that. So it is true for n is equal to k plus 1. If it is true for n is equal to 1, 2, 3, k plus 1, and therefore it is true for any natural number, and therefore the given statement is true according to the mathematical induction. So this is how you have to solve. This is the most important question. So if you follow this, you can do any problem of this kind. And thank you so much for watching and staying till the end.